Hello, my name is Dennis Balicki with ABB, and we're here standing in front of the main electrical equipment, which is the Pico service drop. Before we get started, I have something I need to read. This recording does not purport to be an aid or instructional tool with reference to materials, matters shown in this recording, but it is rather to be viewed as illustrative of certain types of services offered by ABB and its affiliates. ABB and its affiliates accept no liability of any kind, including claims for bodily injury or property damage, which may arise from the use of, work on, or work undertaken on the basis of this recording, and it makes no warranties, representations expressed or implied with acceptance to the accuracy, completeness, or the use of information contained in this presentation. The customer hereby indemnifies and holds harmless ABB and its affiliates from any such claims. If you view or attend this training, you agree to the limits stated herein. So now that we've got the lawyers out of the way, let's start with the real work. Okay, so this is the main service drop where Pico is coming in to provide electrical service for the entire building. On the outside extremities, you have the main circuit breaker and the main circuit breaker. So those are the two, the far ends of the equipment represent the main incoming breakers. In the dead center is the tie breaker, which joins the two pieces of the electrical service together. The second drop that you see in here, where it says Pico transformer on both sides, this is the utility metering. Pico doesn't give you electricity for free, even though you buy it at 14,200 volts. Okay, just telling you guys. So, and then this other unit that you see in here, this is actually a feeder that goes up to the unit substations that we'll be talking about later. So basically, if you walked across the equipment, just so you can kind of get a mental image in your mind, that would be the left main breaker, the utility compartment, the feeder going up to the penthouse from this side. This is the tie breaker, which is normally open. Then the feeder from the right side, the utility cabinet, and the incoming main. The way this equipment normally functions is you have the incoming service drop from the left and an incoming service drop from the right, and the tie is open. That's why you see a green indicating light here on the tie. Green means open. And on either one of the extremes, you'll notice that there's a red light over the control switch. That means red, the breaker is closed. Okay? So the normal function of this equipment is main closed, tie open, main closed. Why do you have a double-ended service? Well, in case something should happen to one of the service lines from Pico, this equipment will automatically transfer. So let's say a thunderstorm comes through the area and you lose one of your Pico lines. What would happen in that particular case is the one line would go dead because Pico doesn't have power to that substation. That breaker will wait a second, well actually it'll wait 3 seconds, because we want to give Pico the opportunity to go through their reclosing cycle. So what Pico usually does is what we call a 3-33. So 3-cycle reclose, 30-cycle reclose, 3-second reclose, and lockout. So if after, that's why sometimes when you're home, your lights flicker and stuff like that, that's usually the 3-cycle. It's just enough to flick the lights, but it's not enough for you to lose power or anything like that. But after the third reclose, they're like, nope, something's really bad, you're not getting power, it sucks to be you. So what happens in that particular case, after the timeout, the equipment will automatically open the breaker that has lost its service. It will automatically close the tie. So that indicating light will go green, this indicating light will go red, and now you're feeding the entire building from the one service. And then obviously if it was another way, you'd go the other way. Yep.
So Dennis, is it safe to say that both these mains are on separate service stations?
Absolutely,
Okay.
absolutely.
I've seen somewhere where they're on the same. If you lose a service station, then it kind of defeats purpose.
That's a really good point. And typically, and what's really nice about Pico these days is they not only give you, the T number, but they also try to, kind of verbally describe, like this is the parish 140, and this is the university 2640. So the fact that those are different names, great point. By the way, thank you so much. If I'm saying something and the question pops into your mind, let's just get that right on the table, okay? Because that's really important. I really probably should have started off with a safety note, so let me just backpedal a little bit on that. This is medium voltage equipment. just to put things in perspective, you know, this is, you know, as you can see up here, 13,200 volts, okay? So this is 100 times more voltage than what you have at your house, because that's usually like 120. So this needs to be treated with the respect that it's due, okay? So, you know, only licensed electricians who are knowledgeable in 15 kV equipment should really be operating this equipment. You know, there's really no reason for anybody, you know, who doesn't fall into that category to, quite frankly, even be in this room, to be honest with you. You know, having said that, I will give you some insights so that if you do have to deal with somebody, you can, you know, and they kind of like, oh, I've never seen this before. You can kind of walk them through what we're talking about here. So why don't we start with this incoming main service? And the other side is pretty much almost the same. So if you want to, you know, move the camera or your, yeah, there we go. Just to give you some insights into the way Pico works, you'll notice you have two protective relays here. One of the requirements of Pico is if you have a multi-function protective relay, okay, they require you to have a backup relay, okay? If you had a discrete relay that was self-powered, you could just get away with one, but everybody uses multi-function, you know, microprocessor relays these days, so Pico had a bad experience with those years ago when they first came out, and so that just became the mandate, and so everywhere you go, you'll see these multi-function relays, they're here. These are the test switches associated with the relay. So again, if you have a qualified electrician coming in and they're doing, you know, secondary current injection testing to test the board or something like that, this is the interface that they would use for their test equipment, okay? And they're clearly labeled, you know, here, this is the one for the, you know, the protective relays, and this is the one for the detective relays, and this is the one, you know, for the meter. So, although these all, you know, this obviously looks different, but, you know, it looks a little bit different than the meter we're going to see upstairs when we do the switchboard. This is, in fact, a multifunction meter by Schweitzer, okay? So these are the protective elements. This is where you have the short circuit and overload. This is the backup short circuit and overload. And this is the meter that gets you your amps, volts, watts, and that's probably connected, I'm guessing, to a BAS system or something like that, so that you can see, you know, how many current, you know, what, and the power that you're utilizing. The next devices that you'll see over here, again, this is where the qualified electrician things come in, but I'm just explaining this to you for safety reasons. This is the 52CS, or the control switch. This is the actual operator of the breaker. You can see it says trip and close. The red is a mechanical flag saying that somebody physically came to this switch and turned it to the closed position. That's why you have a red mechanical flag, okay? The reason this is important is sometimes when you're doing troubleshooting and you have automatic throw over, something like that, you know, you might be closed, but you have a green flag, and you're like, I don't understand. Why is the breaker closed and I have a green flag? Well, it's because the system did the opening and closing of the breaker. It wasn't a mechanical, you know, input from a person. So that's something that can help you with troubleshooting sometimes when you're going through that. The other device that's up here is what we call a lockout relay. Pico only wants competent people to be working this equipment. So if you get a short circuit or an overload on the line, and the breaker does trip because you have, you know, a short circuit or an overload, the relay will sense that, it will trip the breaker, and it will also activate the lockout relay. And what will happen is the light will come on, and this, you get a mechanical flag there. And basically, you can try to close the breaker, but it won't close because the lockout relay is preventing that. So it's a two-step process. You know, you have to undo the lockout relay, then you'll be allowed to close the breaker. But again, this is something that a qualified electrician should do. But the reason I'm bringing it up is if something is going funny in the building, this would be a great place to first take a look at. If you have a red mechanical flag and this white light is on either end of the mains, that means you've had a trip. Now, what could really happen in real life, the scenario would be, rather than a thunderstorm coming through and you lose voltage and you do the automatic throw over and lights blink and everybody's happy because their lights are back on, what would happen in this scenario is car ran into a pole, okay? And electrical lines shorted against each other, and now I've got a short circuit. Well, that's a completely different scenario than I've lost voltage, okay? So what would happen here is the relay would sense, oh, I've got a short circuit. It would trip, it would activate the lockout relay, and you would not get a transfer of your automatic throwover, because basically if I close the tie, I would be closing onto a faulted circuit, and then I would lose both sides, okay? So that's the reason I wanted to kind of walk you through that scenario. So if you ever see the 86 lockout, in the mechanical setting and or the light on, that means something of an unusual nature has happened, and that's the reason why half your building doesn't have power, because something has happened of a catastrophic nature, of a short circuit or an overload, and there's nothing I can do in this equipment to fix it. Okay. So from that standpoint, these the one nice thing about this from an operational standpoint, this is a line VT, so this steps the voltage down from 13.2 down to 120 volts. And we use this not only to sense for automatic throwover, so if we lose voltage, we do a main tie, main closeover, but also this is providing you control power for your 3 breakers. So you don't have to worry about DC battery rack and charger that we have sometimes on these equipment. So don't need to worry about that. Okay, as long as there's power coming from Pico, you will have a line PT that will provide 120 volts to operate your equipment. So just, you don't have to worry about DC close, trip, and charge. So the breaker is down below. This is the instrumentation compartment. That's the VT above. This is our utility cabinet. This is the feeder to the other breakers. And this is sort of like the brain area. We'll move the camera here and just kind of walk you through what's going on here. Again, the way that this equipment is set up right now is a good default way to keep it. Okay, there's no reason for you to really change the settings that you see here. So the first thing that you're going to see here is what we call a pre-select. Okay, this is basically for an extremely well-trained electrician or a Pico service person when you want to do what we call a closed transition transfer. Okay, there's really only those 2 people need to know what this is, but basically it's a pre-select switch that says what breaker do you want to open if all 3 are closed. Okay, again, Pico or extremely medium voltage trained personnel would be operating this. The next one down is a selector, and this is a test switch, okay? This is a way of faking out the system to test the equipment. So it has a normal, it has a main 1, and it has a main 2. So basically, if you wanted to simulate loss of voltage, okay, you can move this to the main 1 position. It would disconnect the incoming voltage sensing from that one side, from the main 1 side, and then it would go through its automatic throwover sequence, just like if you had a power outage. Okay, so that's what that switch is for. Again, authorized, trained personnel only. The next one is probably the most important switch on this whole thing, and this is whether you're doing a normal or a parallel operation. So basically this is open transition or closed transition. Right now it's in the normal open transition. So if you had a situation where you went through this scenario where the power was lost because of the thunderstorm came through, and you're now in a single-ended situation, and somebody says, oh, I want to restore it to its normal with the tie open and the main closed, most of the time my counsel to you would be, well, let's do this in the normal open transition position because that's the safest. So the bottom switch down here is your auto manual switch. It's now in the auto position, so the automatic throwover works. Basically, a person would put it in manual, keep it in normal. You would then open up the tie. Okay, the building would go black. Half the building would go black. Then you go over to the main, close that main, and then you would have power on the left, nothing on the tie, power on the right. Then you would put it back into auto and you'd be all set to go. Most people, that's how they do it. They usually do it like 2 o'clock in the morning when the tenants are asleep or something like that. So they don't worry too much about power outage. So that would be the procedure for doing that. You can do a closed transition, that's when it would be in the parallel, and that's when you would use the pre-select switch. But again, you know, really that's a pico call, okay? Because basically what you're doing is you're connecting the source from one substation to the source from another substation. You know, you want to make sure that the sources are in sync and parallel, and if they're not, then you're basically making a closed bolted fault, and that's why you want to have pico. Okay, so that's basically what's going on with this equipment. As far as maintenance, the big thing here is keep it clean, keep it dry, and occasionally exercise it. Of all the equipment we're going to talk about today, this is the most industrial, this is the most robust, this is the most tank-built type of equipment. This is what we call metal-clad equipment. So basically there's a metal barrier everywhere inside here. There's a metal barrier between the low voltage compartment and the bus. There's a barrier between the breaker and the bus. There's a barrier between the cable compartment and the bus. That's why it's called metal-clad equipment. So it's really very much built like a tank, and so and all the bus bars come insulated whether you want it or not, because that's part of the ANSI requirements. So it's really a very well built industrial robust piece of equipment. So from a maintenance standpoint, really just keep it dry, keep it clean. Now from a cleaning standpoint, one thing we stress with all the equipment is vacuum only. Don't use compressed air, because compressed air can blow particulate matter into places where it doesn't belong, and that's going to create problems. So vacuuming is the way to go. So, from a maintenance standpoint, we usually try to recommend annual maintenance. This you could probably go every other year if you wanted to. The breakers are good for 10,000 operations. That's a long time in breaker land. So, and like I said, the only time I think this equipment is actually going to be seeing some use will be thunderstorms in the summertime when it goes through its auto throw over. By the way, one of the things I do want to emphasize in that situation is this equipment does come what's called with live line seeking. So let me give you a scenario where you don't have to worry about this with this equipment. So going back to our situation where the thunderstorm came through, we lost the right side of the building, the breaker opened, the tie closed, and now we're feeding everything from the left side of the building. Well, this was a particularly violent thunderstorm, okay? But what happened is they fixed the right side, but now you lose the left side, okay? So now you could potentially be in a black building because, the breaker on this side is open, but I've just lost power on this side. The way the system is set up, and PICO mandates that we do this, is called live line seeking. So if that scenario should happen, where you lose power when you're in a single-ended situation, but power is restored from what was a previously lost source, the system will automatically throw over to the other side. So what will happen in that case is this breaker will open, that breaker will close, and now you'll be single-ending from this side. So again, you'll get a blip, but now because that's a viable line and you have line seeking incorporated into your equipment, your building won't go down. So that's just one thing I just wanted to bring to your attention. So, the nice thing about this from an operational standpoint, the fact that you normally have two sources available, the fact that you have automatic throw over if something of an unusual nature happens, the fact that you have live line seeking if something of a very unusual nature happens, it would be rare that you come into a situation where this building doesn't have power. Okay, if it doesn't have power, then something unusual has happened, and that's where the lockout relay that I was telling you about, where somebody, maybe get a transformer downstream and well, I'm single-ended. I thought this thing had, Dennis told me that, because it's on the tape, that this wouldn't happen. And it's like, well, no, he said it wouldn't happen provided there wasn't something of a catastrophic nature, like somebody taking out the line or a transformer or something like that. Then you will be that way. So again, from a maintenance standpoint, if you have the opportunity, it would be good to exercise the breakers, okay? So if you have a period of time,
you know, 4th of July or Thanksgiving or something like that, where occupancy is low, and you send a notice to the people and say, hey, you know, we're going to be, you know, exercising the equipment, you know, that would be a good time for you to do that, because breakers don't like to be left alone. They need to be exercised so that, you know that the spring mechanisms and all that kind of stuff is working fine. So most people, when they have periodic maintenance, you know, they'll have, you know, some sort of testing company come in, you know, once a year, every other year, every third year, and that's part of the thing. They'll come in, they'll do the secondary injection testing, make sure the relays work fine. As part of that, they'll also, you know, operate the breakers and everything like that. Big thing is keep that documented, okay? You really, whenever you go through some sort of maintenance or exercise cycle, make sure you capture it somewhere.
Is there a tighten or torque requirement up here?
There is on the cables, and that's a great point. Thank you very much for making that. That's something I neglected to talk about. So in the back of the equipment, that's where all of your cable connections are made, and they are all cable connections. So your incoming Pico lines are cable connection. Your feeders going up to the substations that we're going to see shortly are also cable connected. So as part of that inspection and maintenance, you know, not only, you know, look at the equipment, not only vacuuming and keeping it clean, not only check that, you know, everything's bolted, although quite frankly, this stuff is pretty heavy, it doesn't move very often, but also, you know, maybe IR scan, or to your point, you know, if we have the opportunity in a de-energized environment to check the torque values on the lugs, then I would also, you know, take that as an opportunity.
So Dennis, I'm from DC, and
Okay.
we have a DC requirement that's every 3 years. So does Philadelphia not have a requirement as far as tighten and torque?
I don't know that
control?
L&I has anything like that, to be
Okay.
honest with you.
Okay, so it's just a best practice then at that point.
Yeah, and if we weren't recording, I could really tell you something.
We'll talk about it. Got you loud and clear.
So, yeah, I don't know anything
Yeah.
like that. I don't know.
We can talk.
Yeah, we'll talk. Yeah.
I just want to make sure that when I put engineers in here, that we're following any type of procedure that the city or state mandates. That's it.
Yep. No, I think it'd be a great thing to do. You know, I strongly encourage it, not just on the medium voltage equipment, but also the low voltage equipment. Keep it clean, exercise, and check for loose connections. That's basically, I'm going to just be repeating that, you know, as we go to the different pieces of equipment. You know, right now, you know, things look pretty good here. You know, the breakers are obviously in this bottom area here. You can kind of see through the porthole here if the breaker is in the connected or disconnected position. Obviously, the breaker has to be in the connected position in order for it to be closed. So that kind of goes without saying. If you have some extra security measures that you're worried about, you'll notice that a lot of the doors have padlocking provisions. So both here and on the back. So, you know, if that's something that, you know, you're concerned about, you can absolutely, you know, put padlocks on those. You can see Pico already has put their padlock onto the utility metering compartment. So they don't want anybody going in there and messing around. I would venture to say if we look around the back, you're going to find a similar type of lock on the incoming cable compartment for that.
Good deal.
Questions? You guys didn't fall asleep, but that's because you're standing up. See, now if we were sitting down, throwing things at you. Okay, yeah, it's you know, again, robust equipment, keep it clean, exercise it periodically, and, you know, it should be around for the life of the building.
Amazing. Thank you.
Yep, okay, let's go on to our next one.
Going up to the substations.
Yep. Why don't we just, you know, I'm gonna go around the backside here just to look at the.
Should I keep it-
Yeah.
Should I keep it rolling?
Go ahead.
So, yeah, you will notice, I don't think you get the camera on, you prefer that or not, but you do have infrared ports here. Are we still recording or? Oh, okay, great. Okay. So we're in the back of the equipment here. You'll notice that all of the equipment has hinged rear doors. There's no panels that need to come off, so that's better from a safety standpoint. You'll also notice at the incoming section and the feeder section, we've got Iris IR ports. So this kind of goes back to the, the maintenance and the inspection type of thing. So you have the ability here to remove that cover and put an IR camera in there, and through heat thermography check the tightness of the connections for the incoming cables on the outside and the outgoing cables on the inside. Okay? That's it.